Hello friends, welcome to my channel again. In today's session we are going to take some more information about Lamport's clock. In part 1 we have seen how Lamport clock works and how the events are ordered using the Lamport's clock. Now if we consider the previous scenario, so we have seen one diagram into that. So in this diagram P1, P2, P3, P4 events were getting executed at node 1 and Q1, Q2, Q3, Q4 and Q5 events were getting executed at node 2. So we have taken detailed information about how the ordering of the events is done using this diagram. We have seen that the events which are local events, so how the time stamping is done to those events, and we have also seen that for the external events how the time stamping is done. But now the thing is that if we have two nodes, node 1 and node 2, node 1 is executing event E1 and node 2 is executing event P, so which are shown in this diagram. So these two events are independent event or local events to these two nodes. Now the thing is that as these events are independent events, so how to decide the ordering of these events? So partial ordering mechanism in Lamport clock does not provide any mechanism for ordering such type of events. So these events are said to be concurrent event. So here as per the diagram, E1 event is getting executed on node 1, P1 event is getting executed on node 2. So these events are considered as concurrent events. So for such events there is no mechanism for ordering these events. So for these events we cannot decide the order of their execution. So these type of events cannot be ordered by using the partial ordering mechanism, and these events are categorized as concurrent events. Now the drawback with the partial ordering mechanism was it was unable to order the concurrent events. So now let's move to the next topic. Let us talk about the total ordering. In total ordering, every pair of event is comparable. So whatever the concurrent events were there in the partial ordering mechanism, so these events can also be ordered using the total ordering mechanism. So in total ordering there is always a clear order of events. Now again node 1 and node 2 are shown. E1 event is getting executed on node 1, P1 event is getting executed on node 2. Now consider that E1 and P1 events are having same timestamps. If this is the situation, then tie-breaking rules are applied for clearly specifying the ordering of such events. To convert the partial ordering into total ordering, we need to add process ID or priority to each event's timestamp, because these two events are happening at same timestamp, so it is difficult to order such type of event using the total ordering mechanism also. So only timestamp will not help us in this case. For that we need to have additional parameter, and that parameter will be either process ID or priority. So this process ID or priority helps us to break the tie when two events have same timestamps. Let us see the conditions for total ordering. Here on node P or on process P, some events are shown, P1 and P2, and on node Q or process Q, two events are getting executed, that is Q1 and Q2. In general, if we say if Pi is an event on node P and Qi is an event on node Q, then Pi is in ordering relation with Qj if and only if timestamp of Pi is less than that of timestamp of Qj and node P has a priority over node Q. This can be the first rule. Second rule can be if timestamp of Pi is equal to timestamp of Qj and node P has priority over node Q. So these are the two rules which can be used in the ordering relation. Let's see the example. Here we will do ordering of events P1 and Q2. Timestamp of P1 event is less than that of timestamp of Q2 and P has priority over Q. So we can say that P1 and Q2 events are in total ordering. Now let us see ordering of events P1 and Q1. So P1 and Q1 events have similar timestamps. So the second condition is like if the events are having same timestamps, if node P has priority over node Q, then we can do the ordering of these events. So here while ordering the events P1 and Q1, we know that timestamp of P1 is equal to timestamp of Q1 and priority of process P is more than that of Q. So it is possible to order the event in this situation. So that's it from this session. Let us summarize a couple of points again. While doing partial ordering of event, it is difficult to order the concurrent event. The problem of ordering the concurrent event can be solved with the help of total ordering mechanism. Hope that you will like this video. Kindly share this video with your friends. Also kindly like the video and subscribe to my channel. Thank you.